So we have a roller coaster car with a mass that is equal to 500 kilograms. It starts from rest, so our initial velocity is 0, at the top of a hill that is 40 meters high. So its initial position is 40 meters. It descends to a height of 10 meters. And if we assume that there is no friction or air resistance, we want to calculate the potential energy due to gravity that is lost by the car. We want to consider the work done by gravity, and we want to consider the speed of the roller coaster at the bottom of the hill. So I'm going to draw a picture first of a roller coaster. So we have this little dude, he's got wheels, he's having fun. This is going to be 40 meters, this location is going to be 10 meters, and we want to find the velocity at that location. So this is going to be a gravitational potential energy problem, where potential energy is mgy. Y is our position on the y-axis. And we also want to consider work done by gravity. Since the work is going to be done by gravity, we can use our definition from the conservation of energy that work has to be equal to a change in potential energy. We also want to find the speed of the roller coaster at the bottom of the hill. This is going to involve some amount of kinetic energy to solve this, because kinetic energy is 1/2 mv squared. That's where we'll get our velocity. And if we recall, we can also set work equal to a positive change in kinetic energy. So the first thing that I want to solve for is I want to solve for the change in potential energy of this car as it goes down the roller coaster. So my change in potential energy is going to be mgy final minus mgy initial. Because mass doesn't change and g is a constant, this will give us that our change in potential energy is mg y final minus y initial. So I can now plug in my values, where my change in potential energy is going to be 500 times 9.81 times 10 minus 40, because 40 is my initial position here. This is going to give me a negative change in potential energy, which makes sense because as this object is falling, it is losing potential energy and it is gaining kinetic energy. It's speeding up as it goes. And this will be 147,000 joules. This is going to be my change in potential energy. It also wants us to figure out how much work was done by gravity. Well, because the only force that's acting on this is gravity, I can just use my definition that work is equal to a negative change in the potential energy, meaning that work is equal to negative my solution I got for my change in potential energy, and my work is just going to be 147,000 joules. The next thing it wants us to find is it wants us to figure out what the velocity is, what the speed of this object is at the end. So I'm going to use my conservation of energy to solve this. So I know that the total energy of the system in the initial condition has to be equal to the total energy of the system in the final condition. So this means that my initial kinetic energy plus my initial potential energy has to be equal to my final kinetic energy plus my final potential energy. If I rearrange this a little bit, I can get that I have the potential energy initial minus potential energy final is equal to kinetic energy final minus kinetic energy initial. I know that this value is a change in kinetic energy. If I pull the negative out on the left-hand side, then I get negative potential energy final minus potential energy initial is equal to this change in kinetic energy. This is now my change in potential energy. So this shows us that our negative change in potential energy has to be equal to our change in kinetic energy, meaning that my change in kinetic energy is going to be equal to 147,000 joules. Because my object is starting with an initial velocity of 0, right? I have 1/2 mv final squared minus 1/2 mv initial squared. This has to equal 147,000 joules. My initial velocity is 0, so this whole term is going to go away. This will give me that 1/2 mv final squared is equal to 147,000, or that my final velocity is going to be plus or minus the square root of 2 times 147,000 divided by the mass, and the mass of this cart was 500 kilograms. Now I have to decide whether I want a plus or a minus for my final velocity. Because I know that this object is going to be falling, I'm going to have a negative final velocity because that negative tells us what direction this object is moving. So if I punch this in a calculator, I get 24.25 meters per second, and that's my solution to this problem.